And if somebody's listening to this without the background in physics, well, just take this as something that you might want to remember when and if you do take a rigorous introductory physics course. Okay, so there's your fundamental theorem, and one consequence of this equivalent statement the integral around a closed path of your gradient is 0 for any closed path C. And if you have a closed path, that means it ends where it started, which means its potential at the end is the same as its potential when you started. So B and A would be the same. So f of B would be the same as f of A. So when you subtract f of A from f of B, you're going to get 0. So without stating that completely, I'll write it like this. So that B equals A, that is your endpoint equals your starting point, and then it should be obvious if your endpoint and this is the same as your starting point, both of these expressions have the same value. When you subtract them, you're going to get 0. And conversely, if when you subtract them, you're going to get 0, then if you have a curve from point A to point B, okay, so you go along the curve this way, and if you know that the integral over any closed interval is 0, then you can complete this path from B to A. Okay, the integral over this path is f of B minus f of A. The integral over this path is f of A minus f of B. And the sum of those two has to be 0. And you can work it out. You'll see this picture. You can work it out that that implies that the integral from A to B doesn't depend on your path. Okay, you can work it out. I don't want to use the time to discuss that, because once you see it, it's pretty obvious, and I think you'll see it pretty quickly. Okay, so that's a survey of conservative fields. Now, there's proofs and examples and more things, but these are the important things to understand.